Thrust bearings, disc friction. Friction between circular surface under distributed normal pressure occurs in pivot bearing clutches bearings, clutch, plates, and disc brakes. To examine these applications, we consider the two flat circular discs shown in this picture. The shafts are mounted in bearing so that they can be brought into contact under the axial pressure force P. The maximum torque which this clutch can transmit is equal to torque M required to slip one disc against the other. If P is the normal pressure at any location between the plates, the frictional force acting on the elemental area is dF P multiplied to the dA as multiplied to mu multiply to dA. The moment of this elemental friction force about the shaft axis can be determined as R P mu dA. dA equals to dr d theta R d theta multiplied to dr. To carry out this integration, we must know the variation of mu and p with r. The following example we will use. Assume that mu is constant. Further, if the surfaces are new, flat and well supported, it is reasonable to assume that the pressure P is uniform over the entire surface, so that we have this relation for dF P is equals to P R to P. With replacing, we can obtain P substitute into this relation dm P on PR to R d theta dr. M equals to mu P axial force PR to integration of R to dr d theta M axial force PR to 0 R to dr d theta. So we can calculate the relation for the required M We may interpret this result as equivalent to the moment due to the friction force mu P acting on the distance 2/3 R from the shaft center. Equivalent to the moment due to the friction force acting at a distance from the shaft center. Substituting the constant value of P in the expression, we get, if the friction disks are rings, we have various case of a study which the R is different from this relation, and the result can be for the rings dm M should be equals to this relation mu P on PR2 integration, and in this case R0 to Ri inner out RO for the disk. After the initial bearing period is over, the surface retains their new relative shape, and the further wear is therefore constant over the surface. This wear depends on both the circumferential distance traveled and the pressure P. Since the distance traveled is proportional to R, consider this picture for a rig shape. After the initial wearing in period is over, the surface retains their new relative shape and further wear is therefore constant over the surface. This wear depends on both the circumferential distance traveled and the pressure P. Since the distance traveled is proportional to R, the expression Rp equals to K may be written, where K is constant. The value of K is determined from the equilibrium condition for axial force, which say that P equals to with PR equals to K. We may write the expression for M. One second of mu PR. The frictional moment for worn-in plates is therefore only 1/10, 2/3, or 3/4 so as much as for new surface. If the friction disk are rings of inside radius R1 and outside radius RO, substitution of these limits give the frictional torque for worn-on surface worn-on for the rings. 1 second. You should be prepared to deal with other these friction problems where the pressure P is some other fraction of R.